Welcome to the lesson on the graphical representation of cumulative frequency distribution. At the end of this lesson, you will be able to define an ogive, also called a cumulative frequency curve. You will also be able to draw ogives for the less than and the more than types of cumulative frequency distributions. Miss Greenfingers has recently completed a tree plantation program for the local schools in her city. In all, 60 schools participated in the program. She has the data of the number of trees planted during the program in a frequency distribution table. Here, the first column displays the class intervals and the second displays the frequency. Can we represent this data graphically? Yes, we can. Recall that you have learned to represent group data using bar graphs, histograms, or frequency polygons. Let's see another way of representing this data. First, class intervals are rewritten using lower class limits only. Next, their corresponding frequencies are adjusted as shown. Now, we have the cumulative frequency distribution of the more than type. Similarly, the cumulative frequency distribution of the less than type is prepared. For this, the data is first reorganized using only the upper class limits of the class intervals. Then, their corresponding frequencies are adjusted as shown. The cumulative frequency distribution of the less than type is obtained. Next, we'll see how this reorganized data is represented in a graphical form. Let's first consider the cumulative frequency distribution of the more than type. This data, if represented graphically, results in a curve, which is called an ogive or a cumulative frequency curve. An ogive is defined as a curve that represents the cumulative frequency distribution of grouped data. To draw an ogive for this data, we will need a Cartesian plane. Here, we'll plot the lower class limits of the data on the x-axis and their corresponding cumulative frequencies on the y-axis. Let's choose any comfortable scale to mark the lower class limits on the x-axis. We'll take a scale of 1 centimeter equal to 10 units, which is equal to 10 trees on the x-axis. Then, we'll label these with the lower class limits of the class intervals. Next, we'll choose a suitable scale to mark the reference points for the cumulative frequency on the y-axis. We'll take a scale of 1 centimeter is equal to 5 units, which is equal to 5 schools on the y-axis. We can label the x-axis as lower limits of data, or simply as lower limits, and the y-axis as cumulative frequency. Next, we'll mark points on the graph that represent the cumulative frequency corresponding to the lower limits of the class intervals. For example, for the lower limit of 5, the cumulative frequency is 60. Similarly, we'll mark the points corresponding to cumulative frequencies of the other lower limits of data. Finally, we'll draw a smooth curve to join all the points marked on the graph. This curve is a cumulative frequency curve, or ogive. Since in this case, the ogive represents a cumulative frequency distribution of the more than type, it is called a more than ogive. Now, let's draw an ogive representing the cumulative frequency distribution of the less than type. The table here shows the cumulative frequency distribution of the less than type. Let's start plotting the ogive for this data. Here's the Cartesian plane. To draw a less than type ogive, we'll plot the upper class limits of the data on the x-axis and their corresponding cumulative frequencies on the y-axis. We'll label the x-axis as upper limits of data or simply as upper limits. Next, label the y-axis as cumulative frequency. Next, we'll choose a scale to mark the upper class limits on the x-axis. Here, we'll take a scale of 1 centimeter equal to 10 units, which is equal to 10 trees planted. Next, we'll choose a suitable scale to mark reference points for cumulative frequency on the y-axis. Here, we'll take a scale of 1 centimeter equal to 5 units, which is equal to 5 schools. Next, we'll mark a point above each upper limit of data on the x-axis corresponding to its cumulative frequency on the y-axis. For example, for the upper limit of 25, the cumulative frequency is 12. Similarly, we'll mark the points corresponding to cumulative frequencies of other upper limits of data. Finally, draw a smooth curve to join all the points marked on the graph. Here's the required ogive. It is an ogive of the less than type. Ogives can also be used to find the median of grouped data. Let's see how this is done. From this table, we can see that the total number of observations of the value of n for this data is 60. So n by 2 is equal to 30. Now, let's locate the value of n by 2 on the y-axis. We'll draw a line parallel to the x-axis from the point denoting n by 2 to intersect the ogive. From this point of the ogive, draw a line perpendicular to the x-axis. The point where the perpendicular intersects the x-axis gives the median of the grouped data. As you can see, you can use either the more than or the less than ogive to find the median of the grouped data. In both cases, the median of the given grouped data is approximately 59. There is another way of finding the median of the grouped data using the ogives. We can draw both the less than and the more than ogives on the same chart. The two ogives will intersect at a point. Draw a perpendicular to the x-axis from the point at which the two ogives intersect. The point where the perpendicular intersects the x-axis gives the median of the grouped data. Note that, by this method, the median of this grouped data is also approximately 59. You have reached the end of this section. Before moving on to the next section, let's recap the key points covered. An ogive, or cumulative frequency curve, is a curve that represents the cumulative frequency distribution of grouped data. An ogive representing a cumulative frequency distribution of the more than type is called a more than ogive. An ogive representing a cumulative frequency distribution of the less than type is called a less than ogive. Ogives can be used to find the median of grouped data. The median of grouped data can be obtained graphically by plotting the ogives of the less than type and the more than type. The x-coordinate of the point of intersection of the two ogives is the median of the grouped data. Hope you enjoyed your learning experience.